Okay, so in this video we're going to have a look at sketching cubic graphs. This is the type of question that we're going to build up to throughout the video. So we're going to have a look at sketching a cubic, showing the points of intersection on the x and y axes, and then also for this last type of question here we're going to be having a look at finding the distance between 2 points on that curve and how we would approach that and all the different sort of topics that we're going to need. So we're going to need quite a good understanding of factorising here. So we're going to look at factorising quadratics within this, and again I'll link all the videos in the description below and I'll sort of mention them as I go on anything that you might need to make sure that you're quite sort of clued up on towards this topic. But to start with, we're going to have a look at obviously just sketching these quadratics, then we're going to have a look at factorising them and then making sure we can sketch it from there and the different types of cubics that we could have to sketch, and then we're going to finish off on this type of question. So we're going to get started on our first one, and here it is. Okay, so I've got a few different types of questions to show you, and we're just going to have a look at sketching them once they've all sort of already been pre-factorised to start with. Now, there's a few different types of cubics that we're going to have to sketch, and just to give you a sort of brief idea of what they sort of look like, we're going to be sketching a type of a cubic that kind of looks like this. So we get like the nice cubic curve that we know, and sort of going through 3 points. We're going to also have a look at sketching cubics that don't actually quite cross through 3 times, but maybe just come up, down, touch the axes and scoot back up again. And then we're also going to have a look at sketching a final cubic, which is like what I call a negative cubic, which is just sloping the other way, and maybe it goes through like this, there we go, and slopes down the other way, where we've got a negative x cubed involved. So these are the 3 types of cubics that we're going to have a look at, where it crosses through the axes 3 times, maybe where it only crosses through the axes once, with that point where it touches it as well in the middle, and then also a negative cubic there where it's sloping down the other way. And we're going to have a look at those 3. And sort of how to approach them and how to make sure that we sketch them nice and accurately. Bearing in mind that obviously from GCSE level we have actually drawn cubics before using a table of values, but for this particular one some of these cubics go so high up the y-axis that sometimes it's just easier just to draw a sketch and just show that we know what they look like, we know where they cross over, but not actually getting a full accurate drawing of them. Okay, so we're going to have a look at those, and let's have a look at approaching this first one. So it says sketch the graph of y equals x brackets, then we've got x plus 2 and x plus 5 in brackets, showing clearly the coordinates of the points where the curve meets the coordinate axes, and that is on the x and the y axes. Now if I just write this out, and we know from sketching quadratics and from solving quadratics back in GCSE as well, even though this is a cubic, we know that these brackets represent the roots or the solutions as to where it crosses through the axes. Now obviously we can find out what they are quite nice and simply just by setting these individual pieces equal to 0. So for this first one here, we've got just an x on its own. So if we set that equal to 0, we get x equals 0, and that gives us our first root or first solution there. The next one in the bracket, and again, obviously you might just know just to flip the sign, but if you just always set them equal to 0, it doesn't actually matter how complicated they get. We get x plus 2 equals 0, so x equals negative 2 for that one. And then following the same logic for the next one, we get x equals negative 5, okay, just flipping the symbol there. So if I want to go about actually sketching this cubic, obviously I just need to draw a nice little sketch of an axis, and they don't have to be perfect. And I just need to put these solutions on the x-axis so that I know kind of what it's going to look like. So we've got x is negative 2, so that's going to be over here somewhere, minus 2. We've got x is negative 5, so actually I need to extend this a little bit because actually it's going just into the negative area, so we've got negative 5 over here. And then we've also got 0. There we go, so I'll just put 0 over there. So I need to draw a cubic that's going through these 3 points. Now let's just move this out of the way slightly. There we go. So in order to make sure this cubic actually goes through, I first need to just think about whether it's positive or negative. Now if I was to expand all of this, and obviously that means having a good understanding of expanding cubics as well, or triple brackets that we looked at GCSE, I'd know that the x part in this particular line equation here, or curve equation, is going to be positive. Okay, I've got no negative x in any of those, so I'm not going to get a negative x cubed. So I know it's going to be sloping in that positive direction as I drew at the start, which is this way, and the majority of them are going to slope this way, but we'll have a look at the ones that don't. So in order to go through all of these points, and I don't have to be, and I'll sort of mention this as I draw it, I don't have to be too careful about how high up this curve goes. It's just the fact that it goes through there and up through there. Obviously if I was to draw this accurately it wouldn't look like that, but it would cross through those points, and that's what's the important part here, is just making sure that that sketch shows the points that it actually goes through. Obviously this peak here might go a lot higher than it does, and likewise the little dip on the other side of that might go a lot lower than I've got it drawn, but as it's just a sketch, what's important is the direction it goes and the points that it goes through on the axes, so I don't have to worry too much about that. Now this is quite a nice one because the y-intercept for this one is at 0 as it crosses through the origin as x is 0. We already know the y-intercept, so I don't have to worry too much about that either. But there we go, there's two ways that you can find the y-intercept. What you could do is you can expand the brackets up there, so you can expand that out and have a look at what's at the end and get the y-intercept. And if we did expand that, the double bracket there expands to make x squared plus 7x plus 10. And then obviously you've got the other x to incorporate, and once you expand that in there, you get x cubed plus 7x squared plus 10x. And as you can see, there's no number at the end, so that y-intercept is 0. So that's one way of doing it. There is another way. You can actually sub the value of x equals 0 into there. And if you sub x equals 0 into this equation here, you get 0 multiplied by 2 multiplied by 5, and because you've got that 0 there, you get the answer 0. So that's another way of finding the y-intercept as well. But hopefully it's quite clear that if it goes through the origin, the y-intercept is 0. But there we go, that's one of them. Let's have a look at our next one. Okay, so this one says sketch the graph of, and we have x plus 1 in brackets squared and x minus 4 on the other one, showing clearly the coordinates where it meets the axes. Now if I write this out, I'm going to write it out, and rather than writing that squared bracket, I'm just going to write two of them. So we've got x plus 1, we've got another x plus 1, and we've got an x minus 4. So in terms of our solutions here, for that first bracket, the x plus 1, we have the solution x equals negative 1. There we go, so x equals negative 1. We've got the same for the next one, x equals negative 1 for that one. And for the last one there, we've got x equals positive 4. Now, here we go. Here's one of our other type of graphs, because when we have these two here, where we have both the same solution, that's where we get this scenario where, and not accurately with this one, but it's where we get this scenario where it comes down, it just touches the curve at that point. So on that negative one there, that's the point where it's just going to touch the curve. So we need to actually go about trying to draw this, but on that negative one there, that's the point where it's just going to touch the curve and it's not going to cross through it. So if I go about trying to draw a sketch for this one, let's see what it looks like. So there we go, draw some axes. We've got points going through at 4, which I'll draw there, and we've also got a negative 1. There we go. And again, we're going to have to try and find the y-intercept for this, but we'll have a look at that once we've actually drawn it. So in terms of actually going about drawing this, let's have a think then about what it's going to look like. So we're going to go through negative 1, and it's just going to touch at that point, and then it's going to come back up and go through positive 4. Okay, so thinking about this curve on the left here, obviously if we need to make sure it just touches at that negative 1 part, it's going to have to be just below the axes there. So we'll have a look. If I try and draw this in, it's just going to touch at minus 1. It's not going to go all the way through, so it's going to have to loop down below the axes and then up through the 4. And that makes sure it's obviously going in that correct direction that we're used to. Now obviously this has a y-intercept crossing here down in the negative part, so we should actually be able to prove that via the equation there and making sure that we can show what that number is. So we're going to find out what this number is just here. So having a look up here at our actual equation, again we've got two different ways of doing this. We could either expand that all out, or we can just sub 0 in. Now subbing 0 in is going to be a lot quicker for us. When x is 0, what does y become? Obviously rather than expanding it all out and seeing what the y-intercept is like that. So if I put 0 in, let's have a look what we get. We get 0 plus 1 in the first bracket, which is 1, so we have 1 squared, and we're going to multiply that by 0 minus 4, which is minus 4. There we go. So we've got 1 squared times minus 4, so that's 1 times minus 4, which is minus 4. There we go. So our y-intercept down there is negative 4. And that goes to sort of show you, obviously, just sort of backs up that little sketch there, the fact that it's going through the y-intercept in the negative part. But there we go, just another type of question there. Obviously we found that when we had, and this is the important part here, when we've got two roots that are the same there, that obviously gives us this point here where it doesn't cross through the axes, it just touches at that point and then goes back down again. And there we go, let's have a look at our next one. Okay, so for this one here, we've got a negative x in the bracket, and if we have a look, we've got x squared brackets 3 minus x. Now if I write out the equation here and write out those three pieces, let's see what we've got. We've got y equals x squared brackets 3 minus x. Now if I write this out into three parts, we've technically, because we've got y equals, the x squared part there is like having an x and another x. And there we go, so we've got two solutions there that are just an x, and then we also have this 3 minus x. Now that minus x part there means we're going to have a negative x cubed. So this is going to be one of our graphs here which is sloping in that negative direction, and we just need to have a look at what those solutions are and actually try and get this drawn on. So for that first one there, we've just got an x, so x equals 0. For the second one there, it's just an x as well, so we've got x equals 0 again. And for the last one here, and sometimes this throws people a little bit, but always just set it equal to 0, look, and we get 3 minus x equals 0. Add the x to the other side, and we get 3 equals x, or x equals 3. There we go, so giving us a solution there of positive 3. Now if we go about drawing this and thinking about what we've got these two solutions that are the same here, so it's just going to touch at that point and not cross through the axes. But let's go about drawing this and see how we might go about it. So draw a little sketch of your axes. We know it's going to cross through at 3, and it's going to cross through at 0. Now to be fair, what you could do is actually find the y-intercept, and it might give you a better understanding of what it's going to look like, and we could actually go about doing that. You didn't have to find the y-intercept last, you could find it first. So if we sub x equals 0 into here, we'll get 0 multiplied by 3 minus 0, which is 3, and 0 times 3 is 0. So we know the y-intercept is going to be 0 as well. So there we go, that gives you a bit of an understanding of what it's going to look like now. We need to make sure it's got that nice negative slope there. So we're going to come down, it's going to touch at the 0 as we've got those two solutions. It will come back up and then back through the 3, there we go. And sloping in that negative direction, it touches once at the 0, and that's our y-intercept. And there we go, there's our sketch of that cubic as well. So there we go, there's 3 examples of some different cubics, how to make sure that you can find the roots or the solutions where it crosses through the x-axis, and then also that little bit of a process of substituting 0 in to make sure you can find the y-intercept. So I've got a few questions for you to have a go at now, and here they are. Okay, so I've got 4 questions on the screen. They're relatively quick to actually go about drawing, so I've not obviously written on there to show all the coordinates of where it crosses the x and y axes, but I still want you to actually find those. So I'm going to sketch these 4 graphs showing where they meet on the x and the y axes. So pause the video there, have a go, and we'll go over the answers in a sec. Okay, so for the first one, now we've got 3 solutions here. We've got the x, which is x equals 0, so we've got x equals 0. We've got the x minus 3, so we get x equals positive 3, and we've got x equals negative 2. There you go. Now it's a positively sloping cubic graph, so we've got no negative x cubed in there. So we just need to make sure it crosses through at negative 2 and 3, and the y-intercept is going to be 0. Obviously we've got this 0 one out here, so it crosses through on the intercept, on the origin there. So it's going to go up through minus 2, down through the origin, and then back up through 3. And there's our first one. On to the next one, I'll go to the right. We've got x equals 1, and we've got 2 of those. So we've got x equals 1, and x equals negative 3. So obviously bearing in mind here that we've got one of these scenarios where it's just touching on the 1 and not crossing through. So if we go about drawing this one, we've got negative 3 and 1. And obviously we just need to find out what that y-intercept is, and I'll find that one first for this one. So if we sub 0 in, we get minus 1 squared multiplied by 3. Negative 1 squared is 1, times by 3 is 3. So we've got that positive y-intercept up here of 3, and we just need to make sure it crosses through all of those points. So it's positively sloping, goes up through the minus 3, back down, touches at 1, and then goes back up again. And there we are, there's our second one. On to our third one. We've got 3 solutions here, not forgetting that that is x squared, so that's x and an x. So we have x equals 0. We've got another x equals 0. And that final one in the bracket, we've got 4 minus x. And again, if you set that equal to 0 to solve it, 4 minus x equals 0. Add the x to the other side and you get x equals 4. There we go, so we've got x equals 4 as our last solution there. Right, there we go. Now, obviously just being careful here, this has got a minus x in it. So if we were to expand that, we'd get a minus x cubed. So it is negatively sloping. So just obviously bear that in mind. If you can always draw a little slope just to the side, just to remember what it's going to look like. But it's going to cross through at 0 and it's going to cross through at 4. And again, obviously, as it has a solution of 0, that is going to be our y-intercept as well. But it's just going to touch at that point. So we're going to come down, it touches at 0, scoops back up and then down through the 4. And there we go, there's our third cubic. And our last one here, we've got 3 solutions. We've got x equals 0. We've got x equals negative 2 in that one there. And that final one, again setting that equal to 0, 3 minus x equals 0, so x equals 3. There we go, and x equals 3 for our last one. Right, okay, so again, be careful because that has got a negative x in, so that's going to be negatively sloping again. So I'll quickly just draw a little sketch just so I remember which way it's sloping, and then we can go about actually drawing it. So it's going to go through 0, it's going to go through -2, and it's going to go through +3. Right, there we go, so drawing this in, it's going to go down, up through the 0, back down through the 3. There we go, and it's going to look something like that. And again, obviously not stressing about how high these little curvy parts go, the peak of those. Okay, and just making sure that you're obviously sketching it in the right direction and through those correct roots or solutions there on the x-axis. But there we go, let's have a look at obviously extending this slightly and getting the full equations and drawing it from those. Okay, so a very similar process here, but we have sketched the graph of y equals x cubed minus 6x squared plus 9x, showing clearly the coordinates of the points where the curve meets the coordinate axes. Now at the moment, obviously we've got the full equation here that needs factorising first. So we have x cubed minus 6x squared plus 9x. Now these are the nicer versions of the cubics, because these are nice and easy to get a nice little quadratic out of them in order to factorise quite nice and simply. If we went much more complicated on these, we'd have to use the factor theorem, and obviously that sort of starts incorporating quite a lot of maths. So we get quite a large question if we were to do that. But obviously check out the factor theorem if you want to have a look at factorising some of the harder cubics here. But we're going to just focus on some of these slightly easier cubics for drawing these, as it can get quite complicated otherwise. But let's have a look. Now in order to factorise this, we can take out a factor of x to start with, and when we take x out, as there's no number at the end, we get inside a nice quadratic here. We get x squared minus 6x plus 9. Okay, so that obviously gives us our first solution there. We've got x equals 0 for that x on the outside. Now we can go about factorising this quadratic. So obviously if we turn this into a double bracket, our factors of 9, we can have 3 and 3, or 1 and 9. And if we want to make -6 in the middle, it's going to be -3 and -3. So x minus 3, x minus 3. There we go, and we've got that x on the outside. So there is the equation of our graph if we factorise it. And then obviously again that gives us our three solutions. So we get x equals 0 for that one there. We get x equals 3 for this one here, and x equals 3 for this one here. And again, we know there's no y-intercept because we have no number at the end of this equation here. So we know the y-intercept is going to be 0, which we've also proved just via this solution here of x equals 0. So we can go about just drawing it just like we did before now. So draw your axes, it's positively sloping, it goes through 0, and it goes through 3, and it's just going to touch on 3 as well, as we've got those two solutions here of 3. So in actually just drawing that, and not forgetting, this isn't the nicest one to be fair, because we've got two solutions at 3, so you just need to watch out obviously the fact that it's sloping up, and it's going to go up through the origin. Oh, let's do that again, up through the origin, down, just touching at 3, and then sloping back up again. Right, there we go. So no y-intercept, well, the y-intercept of 0, and obviously those two solutions on 3, so just touching on the 3 point there. But there we go, that's that question. Let's have a look at another one. Okay, here we go. So sketch the graph of y equals x cubed minus 9x, showing clearly the coordinates of the points where the curve meets the axes. So in terms of our equation this time, it's not really any harder than the last one. We've just got something slightly different in this one. We've got x cubed minus 9x. Now again, if I take that factor of x out to start with, we get x brackets, and then we get x squared minus 9. And there we go. Now hopefully you remember, obviously from GCSE, you've got a difference of 2 squares in that brackets right there. You've got x lots of, and that x squared minus 9 is a difference of 2 squares. So if we factorise just that bit on its own, obviously the factors there of 9 are 3 and 3. Obviously to make sure it's a difference of 2 squares, we have the two similar or the same numbers in the brackets. So we get x plus 3, and we get x minus 3. There we go, and that's how that factorises, and obviously we've got this x on the outside again. So there we go, we've got our three solutions. We've got x equals 0 at the start, we've got x equals -3 on the middle one there, and we've got x equals positive 3 on this one here, and again it's a positively sloping, there's no negative x cubed there, so we just need to go about drawing it again. So nice and quick, drawing an axis, we've got -3, we've got 0, and we've got positive 3. And we just need to obviously draw this, and again we've got a y-intercept of 0. So it goes up through -3, down through the origin, up through +3, and there's the sketch of our cubic. Right, okay, so before we move on to some slightly harder questions here, or our last questions that we're going to have a look at, here's a couple of these for you to have a go at. Okay, so there's 2 questions here, so pause the video there, have a go at these, I'll go over the answers in a sec. Okay, so for this first one, now taking this up here, if we factor out the x to start with, we get x brackets x squared plus x minus 6. Now we've got 6 at the end and 1 in the middle, 1x there, so that's going to be 3 and 2 when we factorise that. Positive 1 in the middle, so it's x plus 3 and x minus 2, obviously with the x on the outside. So there we go, we get our 3 solutions, didn't need to draw a bracket there, we've got our 3 solutions here, we've got x equals 0 for the x on the outside, we've got x equals -3 for that middle bracket, and x equals +2 for the one at the end. There we go, so if we go about drawing this one, let's have a look, positively sloping again. There we go, so you can always just draw that in. We've got -3, we've got 2 and 0, and actually just drawing this quite nice and simply, there we go, up, down and through the 2. And there's your cubic. On to the next one, we've got x cubed minus 16x. So again, if I factorise that, take the x out to start with, we have x brackets x squared minus 16. And there we go, got our difference of 2 squares there. So we've got the x minus 16, the x squared minus 16, sorry, is x plus 4 and x minus 4. You can do that in either order, obviously. And then we've got our 3 solutions there. So again, we have x equals 0, x equals -4 for the one in the middle, and x equals +4 for that last bracket there. So drawing this, nice and simply, just like the last one, draw our axes, we've got -4 and +4, 0 in the middle there where it crosses through, and here we go, up, down, back through the 4. And there we go, that is our cubics. Now we're going to have a look at something slightly harder here, incorporating a little bit more maths, but obviously we've got one to have a go at, one for you to practice, and that's going to be the end of drawing cubics, so let's have a look at that now. Okay, so this question says, sketch the curve C with equation 9x minus 4x cubed, showing clearly the coordinates of the points where the curve meets the coordinate axes. The points A and B lie on C and have x coordinates of -2 and 1 respectively. Show that the length of AB is k root 10, where k is a constant to be found. So we've got quite a lot of stuff going on here. Now the first element obviously says to sketch this curve. So we need to go about factorising it, we need to go about accurately sort of drawing on those roots and any y-intercepts, and then we'll have a look at these points A and B, and we'll have a look at obviously showing that on the diagram and sort of looking at this visually. So first things first, let's go about sketching this. So our equation there is 9x minus 4x cubed. So again, if we take the x out, we get x brackets, and then we get 9 minus 4x squared. Now that's not very nice, obviously just taking note of the fact that we do have a negative x cubed here, so it is going to be sloping in our negative direction. But this isn't obviously the nicest to look at. Now we have got a difference of 2 squares there, but just with a negative x squared. So in terms of factorising that, I take that first number, square root that, it's going to be 9 plus 2x, sorry, 3 plus 2x and 3 minus 2x. So it's very similar to the one that we've just looked at, but it's just a different difference of 2 squares there. It shouldn't hopefully throw you again. I will link difference of 2 squares in the description, but it's just a little bit of a different double bracket there to factorise when we have a difference of 2 squares. With a negative x squared, you obviously don't see them as regularly in GCSE, but hopefully one that you recognise, obviously from nice simple difference of 2 squares, something like 4x squared minus 9 or something like that, and you get 2x plus 3 and 2x minus 3. This is just obviously with the negative in the mid on the x squared instead. So let's obviously have a look at drawing this then. So we've got 3 solutions, not the nicest of solutions still. We're going to have to figure these out nice and carefully. The first one's okay, we've got x is 0 for our first one. That middle one then, let's have a look at this, 3 plus 2x. Again, you can always just set it equal to 0. So if I say 3 plus 2x equals 0, minus 3 from both sides, we get 2x equals -3. Dividing by 2, x equals minus 3 over 2, or minus 1.5. So there we go, we've got minus 1.5 for that one. And then if I have a look at the next one, oh, don't want to get rid of that. Won't let me get rid of the highlighter, let's just go for a different colour. Okay, so we've got 3 minus 2x for that one. And again, if we solve for that one, and again just set it equal to 0, You get 3 minus 2x equals 0. Add the 2x to the other side. 3 equals 2x. Dividing by 2. 3 over 2 equals x, or 1.5. So there we go, we can draw these on. We've got a bit of working out there. Obviously you might just be able to do those without the working out, and that's fine as well. But I'm just going to stick with the working out and draw this in. So we get 0 as one of our solutions there. We've got 3 over 2. Sorry, negative 3 over 2. And we've got positive 3 over 2 as well. So not forgetting, obviously this is a negative x cubed. So it's going to slope through in that particular way. So I'm going to get rid of all of this working out here. And we're going to draw this in. And it goes down through the negative 3 over 2, up through the 0, and then back down that 3 over 2 just there. So that is our quadratic sketched, and now we're going to have a look at this next part, which is asking us to label, well, not necessarily label them, but to find the distance between 2 points. So we've got point A and point B, and it says that they've got coordinates of negative 2 and 1. Now negative 2 is obviously just beyond that negative 3 over 2, negative 1.5. So if I want to draw that in, maybe I'll just extend this slightly, and maybe I'll just extend my curve a little bit just so I can get a bit of an accurate diagram. Okay, so negative 2 is around about here in terms of a sketch. So that point is going to be somewhere here. Okay, so just sort of imagining where that is, that's point A, let's call it. Point B is at x coordinate 1. Now 1 is obviously before the 1.5, maybe somewhere like here. Let's call that 1, 1. And this is point B. And it just wants us to find the length between those two. So if I was to draw a little line sketch in, let's have a look. We imagine it's this line here. In fact, let's just draw a straight line. And we're going to find the length of that. And obviously thinking back to GCSE as well, if you're finding the distance or your coordinate geometry, if you're finding the distance between 2 points, we just need to think about it in terms of a right angled triangle and in terms of Pythagoras. So if I draw my little rise over run, or my change in y over change in x sort of thing, I can have a look at that. Obviously not changing y over change in x, that would work out the gradient, but our change in y and our change in x. Now in terms of actually finding those, we need to just find out what these coordinates are. And we know what the x coordinates are. We've got negative 2 and we've got 1. So to find the y coordinate, or the corresponding y coordinate for them, I just need to sub them into my equation. Now it says obviously our equation right at the start, we've got it up here. We have got y equals 9x minus 4x cubed. So if I write that down here, we've got y equals 9x minus 4x cubed. I want to find out what the y coordinates are at these 2 points. Now 1 is probably the easier one, because obviously we just substitute 1 in, that's going to give us quite a nice one. So if I sub 1 in, we get 9 times 1, and let's write this in, when x equals 1, we get 9 times 1, take away 4 lots of 1 cubed. So 9 times 1 is 9, take away 4 is 5. There we go. So the y coordinate just there is going to be 5. So that coordinate there is going to be 1, 5. And for point A, which is not necessarily any harder, but a little bit harder, because we have x equals negative 2. So we have 9 lots of negative 2. And then we're going to take away 4 lots of negative 2 cubed. 9 lots of negative 2 is negative 18. So we have minus 18. And then we're going to take away 4 lots of negative 2 cubed. Now negative 2 cubed is negative 8, and 4 lots of negative 8 is negative 32. So 4 lots of negative 8 is negative 32, and obviously we're taking that away. So it's going to be take away negative 32, which is plus 32. So negative 18 plus 32 gives us the value 14. Okay, so there we go, that coordinate up there is going to be minus 2, 14. So now we can find the distances between them and think of it in terms of our little right angled triangle that I've drawn in there. We've got, it goes from negative 2 along to 1, which we could already work out. The distance across the x-axis there is a distance of 3. And we've got a height change of 5 up to 14, which is a height change there of 9. Okay, 14 take away 5 is 9. So in terms of our right angled triangle there, obviously we can just apply a bit of Pythagoras and work this out, the distance between them. So obviously I just want to do 9 squared add 3 squared, and let's have a look what that is. So 9 squared plus 3 squared is 81 plus 9, comes out as 90. We need to square root that to find that distance, and root 90, it says down here, show that the length of AB is k root 10, where k is a constant to be found. So we just need to simplify this third here. So root 90 can be written as root 9 times root 10. Root 9 is 3, so that is 3 root 10. There we go. So our final answer comes out as 3 root 10, where k is 3. And there's our final answer. And thinking about all the different maths that we've done into this one, let's have a think. So we obviously factorised the equation there, used that to find our 3 roots, obviously thinking about the fact it was negatively sloping, and drawing those in, setting those brackets equal to 0 for those more complicated roots there. Once we drew it in, we identified where A and B lay on the graph there just by using those x coordinates and subbing it into the curve. That gave us our y coordinates. Thought about that visually. And then obviously use those coordinates to find the distances between the two by thinking about using Pythagoras, finding the height change between them and the length change between them there in terms of the change of x and change of y. Obviously that resulted in us getting a value of 90, so when we had to square root that, we obviously just used our little bit of simplifying surds to get that in the form that the question wanted. So there we go, there's a lot of maths going on in that question there, but it's just sort of linking all these different bits of maths together and actually thinking about how to apply them and what time to apply them. So it's quite a tricky question there, but I've got one for you to have a go at before we move on, so here that one is. Okay, so here's your question, so pause the video there, have a go, we'll go over the answer in a sec. Okay, so for this first one then, now we need to first factorise this and get our solutions. So if I take my factor of x out for this one, we get x brackets, and then we get x squared minus 8x plus 16. Factorising what's in that bracket there, we've got two factors. We can either have 1, 2 and 8, or 4 and 4, 1, well, or 1 and 16 as well. But in order to make minus 8 in the middle, it's going to be x, and then we've got x minus 4 and x minus 4. Okay, so our solutions within that, let's have a think. We've got x equals 0, we've got x equals positive 4, and we have another x equals 4, so it's just going to touch the curve, touch the axes at one point. So let's go about drawing this in. So sketching our axes, it's going to go through 0 and it's going to go through positive 4. Okay, so this one is positively sloping, so we've got a positive slope, and we just need to figure out how we're going to draw this one. So obviously it goes through 0, so let's have a think about drawing this. So it goes up through 0, it comes down to the 4, and then slopes back up again. So that's how this one's drawn. We've got a y-intercept of 0 there, and we just need to think about these points. So we've been given two coordinates now on the next bit. It says points A and B have x coordinates of 2 and 5. So let's think about where these would be. So 2 is going to be somewhere here in between the 0 and the 4. So 2 there. And 5 is going to be just beyond the 4. I'll just extend it a little bit, but there we go, there's 5. So we've got this coordinate here for 2, and we've got another coordinate here for 5. Okay, so let's draw that in. There we go, we've got a straight line. It's not the longest of lines for this one, but there we go, that's the line that we're going to work out. And obviously it says in the question here, show that the length of AB is k root 2, where k is a constant to be found. So we're going to find out what that number is again. Now obviously we can draw our little right angle triangle in. It's going across from 2 to 5, so we can already really work out that change in x, and then it's coming down as well, and we're going to work out that distance. And remembering it's not going to look that accurate based on our diagram unless you've drawn this absolutely perfectly, but the length from 2 across to 5 is a distance of 3, and we just need to find out what that height change is. So let's have a look at actually finding these coordinates. So if we substitute these x values in, our equation is up there, x cubed minus 8x squared plus 16x, and if we sub them in, let's see what we get. So x cubed minus 8x squared plus 16x, and we've got x equals 2 and then x equals 5 to substitute in. So if we sub x equals 2 in, let's see what we get for that. 2 cubed is 8, so we get 8, take away 8 lots of 2 squared. 2 squared is 4, so 8 times 4 is 32, so take away 32. There we go, and then we have got add 16 lots of 2, so add 32. There we go, so we've got 8, take away 32, add 32, and that gives us a value of 8. So that coordinate there, we can write that one in. We have 2 as our x coordinate and 8 as our y coordinate. There we go. And then moving on to the next one, we've got when x equals 5, and what we're going to get for that. So subbing those in, we've got 5 cubed, which is 125. Take away 8 lots of 5 squared. 5 squared is 25. 8 times 25 is 200. So take away 200. And then we're going to add to that 16 times 5. So 16 times 5 is 80. So we're going to add 80 to that. There we go. And when we simplify that all down, so we've got 125 take away 200 is negative 75. Add the 80 is 5. There we go. So we get a y coordinate of 5. Let's label that on. So that point there is going to be 5, 5. There we go. And that gives us our change in y that we can find now. It goes from 5 up to 8 on those y coordinates. There we go, the 8, 5. So that gives us a height change of 3 as well. So there we go, there is our right angled triangle. It is 3 along and 3 down. So our working out for that then, using Pythagoras, we'll do 3 squared, add 3 squared, which is 18. And then we want to do the square root of 18. So the square root of 18. And let's have a think, how do we get that as a root 2? That's going to be some root 9 times root 2. And root 9 is 3. So it's 3 root 2. There we go, and that is in the form that the question wants it. So there we go, there's our final answer, 3 root 2. Obviously very similar to our last one, except we had a positively sloping one this time, and actually the roots were a little bit nicer on this question. But there we go, that's how we approach these questions, obviously drawing cubics, whether that's from you know, a cubic that's been already factorised, or whether we have to factorise it ourselves, and then obviously thinking about how this can apply to a slightly harder question like this, and how we'd obviously take it through all of those steps and apply, you know, other little bits of coordinate geometry here in terms of getting our answer. But there we go, that is sketching cubics. Hopefully you found that useful and helpful. If you did, please like, please comment, please subscribe, and I'll see you for the next one.